Pipe expansion and contraction will occur when piping is subject to temperature changes. These changes in temperature can be a result of the internal fluid being used in the process, or a result of a change in temperature of the external environment. Uncontrolled expansion and contraction of the piping can cause damage to the piping or components. If the amount of temperature change that will occur is known, as well as the type of piping material being used, then the amount of expansion can be calculated and appropriate control measures can be taken. Here is the equation for calculating the linear expansion. You can see there are three variables in our equation. The first one, COE, will pretty much explain the other two. COE stands for coefficient of expansion. You are given a table in your reading material. Let's have a look at it. You can see on this table we have three columns. The first one is to select the type of material that we are using, as each material expands at a different amount. You will then select either the second or third columns depending on whether you are working with imperial or metric temperature change. For example, if you're working with carbon steel and the amount of temperature change has been calculated using degrees Fahrenheit, you will use the coefficient of expansion of 0.000065. Whereas if you were using the Celsius scale for the temperature change, you would use the COE of 0.0000117. If you were to compare the Celsius COEs to the Fahrenheit COEs, you would find they are all 80% larger, as that is the difference between the two temperature units, meaning 1 degree Celsius temperature change would actually be 1.8 degrees of Fahrenheit change. So of course the piping would expand 80% more. For every 1 degree Fahrenheit of temperature change, the steel pipe will expand by this amount per unit of length. Therefore, those are the other two variables we'll need to know: the total starting length of piping and the total amount of change in temperature that will occur. Let's do an example together. So here's our formula. Let's say you have 100 feet of copper tubing that's going to be exposed to a minimum temperature of 50 degrees Fahrenheit and a maximum temperature of 150 degrees Fahrenheit. So let's plug in our variables. When we check our table, we find the coefficient of expansion for copper using Fahrenheit is 0.000093. So we fill in that number. The starting length is 100 feet. The temperature change needs to be calculated by deducting the highest temperature from the lowest temperature, which gives us a total change in Fahrenheit of 100 degrees. Now we could actually do this calculation in our heads, as we are simply multiplying by 10 4 times. So we can move our decimal over 4 places, and we get 0.093. But what is 0.093? Well, it's the total amount of expansion in whatever units we used in the formula. So we used the length in feet. So this number is 0.093 feet of expansion. Now often you'll be asked to express your answer in imperial builder's measure, which is a two-part calculation. You will need to multiply this number by 12 to get it into inches, and by say 16 if you wanted to the closest 16th of an inch. So the total expansion when the tubing changes temperature by 100 degrees will be almost 18/16, which reduced works out to 1 1/8 of an inch.